Hello, third grade. We are going to continue our unit 2, which we have been discussing force and what force is. We're going to review some vocabulary words. We're going to talk about the projects we've done so far in this unit. And after this mini lesson on forces, you are going to watch a brain pop video and then take a brain pop video quiz where you are going to be reviewing a lot of the vocabulary discussed in today's lesson and in past lessons. So let's get to it. What is force? What is force? Take a look at this video here, and this was our opener, and watching the kids play soccer. Let's pay attention to the ball. What is happening to the ball? Notice in order to move and to cause motion, because the point of the game is to get the ball into the goal, right? In order to do that, you need to apply a certain amount of force to that ball. A bunch of people do. And so how is force applied to that ball? Are you pulling the ball? Are you pushing the ball? If you said pushing, you're correct. You have to push that ball. But how much force should you give that ball? Well, that depends. If you're really close to the net, you probably don't want to give it too much force because you could possibly risk the chance of it hitting the pole and bouncing back at you. You need to be very precise, right? So what if you're very far away from the net? You probably need to give it a big push, a big amount of force. Or what if you're just passing it to your team player? What kind of force would you give that? Give the soccer ball then. So that's what we're going to talk about today. We are going to talk about strong and weak forces. Let's come down here to our vocabulary. And a force, like we said, a force is a push or a pull, which may cause a change in an object's motion. Motion is a big one there. Now, pushing and pulling an object is not the only example of force, as we discovered in our parachute lesson, for example. In our parachute lesson, we had to consider gravity, which is an invisible force that pulls objects towards the center of the earth. Now, we also had to think about air particles and how they push against our parachute, the top of our parachute. We needed our parachute to be wide enough to catch as many air particles as possible so it would slow down the drop. Because no matter what, there's a force pushing that parachute down. Now, our goal was to keep Santa safe, so we couldn't have that force of gravity to be too strong. So how did we manipulate that? Well, we had to create and engineer a parachute that could catch enough air particles to slow down that parachute. So we didn't want the force of gravity to be strong for a parachute to work. We wanted to manipulate the force of the air particles to slow it down. Because we knew that gravity really pulls at objects. What goes up must come down. So we are going to be working on page 74 today in your HMH Science book. So what I want you to do now is go grab that book, because for your exit ticket today, you are going to have to read to me the responses that you're going to make in today's science book. So make sure you get your science book. You might need to pause this video so you can go get your science book. And you are going to turn to page 74. So on page 74, we are going to explore strong enough. So remember, you need your science book, and if you haven't gotten it, you need to go grab that now, because for your assignment today, you are going to have to read me out loud your responses. We are going to complete 74 and 75 today. So here, our objective today is we are going to explore the strength of force, and how it's related to weight, okay? And we are going to evaluate different objects and the amount of force that requires to be applied to it. We are gonna examine the amount of force being applied to certain objects. And we are also going to look at cause and effect relationships in relation to force. So read along with me. We are on page 74. Strong or weak. Now, a force can be weak or strong. You can tap lightly on a door by using your fingers to create a weak force. Go ahead and tap lightly somewhere and create a weak force. Or you could use your fist to apply a strong force to knock loudly. Now, the strength of any force can be changed. If your friend across the room doesn't hear what you say, you can put more force into your voice. So here they are discussing that force is not only something that is acted upon solid, tangible objects, like a soccer ball, for instance. This is kind of introducing you to the type of force that projects sound, okay? The kind of force that projects sound rather than motion. Now, making a sound does involve a push of particles of air, and the result is sound waves. So yes, you are still, when we scream loudly, you are pushing. There's a pushing of air particles coming out, creating sound waves. And the more force you give your voice, the more air particles are pushing out and the louder those sound waves are going to be. So think about force with an open mind. Just like before, when we had to think about forces that are invisible, such as air particles in our parachutes, and we had to think about gravity, okay? Now, think about it how, in this paragraph, it talks about how it can influence sound, not just motion, okay? Not just motion we can see. So let's look here at the pizza problem. Is a stronger force always better? It's a question. Look at what happened when different sizes of force were used to make pizza, okay? So we're going to examine these pictures. Your pictures may look a little different in your book, but we are going to examine all the ones on my screen along with what is in your book. So our goal here is we are thinking to ourselves, is stronger always better? Is a stronger force always better? Well, let's look. So in this picture, we have a man, he's tossing up pizza. Now, we'll start here. He's tossing pizza, he's making pizza. Now, dough is super flexible and super sticky and stretchy. You need enough flour to make it not so sticky so you can manipulate it and move it. But you need to apply a lot of force to pizza dough to get it just the right size that you want it in order for it to fit on the pan and fit all your toppings on it. So yum, right? I'm hungry now. There's nothing better than homemade pizza. The pizza maker uses force to roll out the dough. So is stronger better in this situation? Does he need a lot of force to roll out the dough? What do you think? If you said yes, I agree with you. You must apply a lot of force as you're pushing the rolling pin. You're pushing and then you're pulling back. A lot of force is being applied when you are trying to stretch out that dough to make it the size that you want. Let's look at the next picture. Now, here, the pizza maker pushes the pizza crust into the air with a gentle force. Oh, he looks pretty satisfied about that. What do you think is happening? Yes, you're right. I hope you're talking to me out there. Yes. So when you toss the pizza dough up in the air, the purpose of that is it helps. The force of the toss spins the pizza dough around and expanding it. Okay. So you roll it out just a bit. Now I don't do this method when I make my pizza. This is a difficult task. You need just the right touch. But he is obviously a professional pizza maker here. So he pushes the pizza crust into the air with a gentle force. And look at it go. Now, let's see what happens when he uses a strong force. This time, he uses a strong force. Which crust will come out better? Well, this is an easy one, right? Look what happened to the crust that he was tossing. The crust he tossed up in the air with a strong force ended up on the ceiling. What good is a pizza on the ceiling? That's definitely, I don't think that's something he was aiming for. So what was better here? Is stronger force always better? Not always, not in this case. So in your book, you have two photos and you need to look at the force that the pizza maker is making in both those photos. And I need you to choose which picture does the pizza maker use a weaker force? Which picture shows the pizza maker using a weaker force? After you mark that, let's move on to nothing but net. Here, we are going to evaluate the force that's being applied to the basketball here. Now, the goal of basketball is to get the basketball into the net. Well, how do you do that? Well, you have to throw it. You have to have just the right touch, right? So is a weaker force always better? Well, we're going to examine that same question here in the book. Look at what happened when different sizes of force were used to play basketball. So we're going to examine this. She throws the ball. Oh, I always start at the end. Let's look at this one first. In this picture, this girl is lining up her free throw shot. She looks like she knows what she's doing. She's lining up her free throw shot. First, she throws the ball with a gentle force. What do you think about that? Gentle force. Is a weaker force always better? Let's see what happens when she applies strong force, a stronger force. It says then she throws the ball with a strong force. I'm not sure if she's going to make that basket, but it looks a lot better than the first one. She's aiming to shoot that ball in the basket. So put an X in your book. You have similar pictures. Put an X in the circle on the picture that shows the girl using a stronger force to throw the ball more accurately. And this is what you're going to have to answer for me in your book. What would happen if you threw a basketball with too much force? What would happen if you threw a basketball with too much force? I want you to think about the objects we discussed here. I want you to think about the pizza maker, and I want you to think about the little girl in the picture. In our examples up here, it looked like she threw it with a gentle force here, and then a little bit stronger this time. But what if she applied too much? The term is too much here. Too much. What would too much do? So I want you to write your answer on your lines on page 75. On page 75, write your answer to that question. On Schoology, you are going to read me your response out loud, so make it a good one. And then you are going to give me an example of weak and an example of a strong force. So you can find an object for this one, and I want you to, in your video response, show me an example of weak and show me an example of strong.